Okay, this is my final project screencast for C++ 2361, my blackjack game. And of course, everything is on the screen and easy to see so that we'll be able to follow along. My name is Andrea Davis, and just to go over a few things with my game, I've used a few global constants for the card numbers, the suit, and the deck. And I included structures for my players, for the dealer, and for the deck to track the deck as the cards were being dealt. Of course, there's tons of functions, but we start out the game with a variable for the number of players at 0, and we start the overall game with start BJ, and we set it at false, and we have a new game, which is a new hand. So the overall start BJ is to start the official game from the very beginning, but the new game is as each game is played and the dealer either breaks or wins and everybody loses, that sort of thing. That's what the new game controls. We have a welcome message that welcomes everybody. And of course, once we go through the welcome message and get the number of players, then the start BJ is changed to true. And at that point, we request how many players there are. And we have an error handling for the limit of the number of players. My game only allows minimum of 1 player against a dealer to a maximum of 6 players against a dealer. And so if that number goes above 6, then it kicks out an error and asks them to re-enter the number of players again. It goes over to the next screen and we initialize a struct called players to keep the number of players that are in the game and to keep track of their hands and their cards and that sort of thing. We also have an error handling to make sure that there's enough memory to allocate for that. And then we call the user logins at that point, and then we set the new game to true so that now we have a new hand that's being dealt to all of the players. Once a game is initialized, the new game is initialized to true, we go in and we set all of the players' cash on hand, blackjack, their track wins, and their track losses to 0. The BJ variable that's part of the struct keeps track of when a player gets blackjack. So whenever their hand pulls out a blackjack, it's dealt with accordingly, but it converts from 0 to 1 when that player has blackjack. So to start the game, we make sure that all of these variables are initialized to 0. We then call the set cash, which is where the players will go in and purchase or put in the amount of cash that they want to start the game with, whether it's $100, $200. And we will display their name at that point and the amount of money that they have total. And then we go in and initialize or basically create the deck. So the deck is set up in strings as opposed to variables. Strings as opposed to ints, so that we can create hearts of 4 or 4 of hearts and 4 of diamonds, that sort of thing. We call a function to create the deck, and we also initialize a variable to track the decks. And this is part of that deck structure, to track the cards as they come out of the deck. And we created a var for the dealer as well. And we started a while loop that will mimic a little ... as the cards are being shuffled, but obviously that happens in a nanosecond, but we pause the screen just for a second to make it a little user-friendly for the viewer. After that is done, we call the shuffle cards, where we'll shuffle the deck of cards, and then the players are prompted to submit their bets for the particular hand. There is a $5 minimum on my game and a maximum of $100, and we call a function to do that. We initialize the card values for the players on the game, so we make sure that their card value is at 0. The card value is a variable that tracks the total value, which will tell the computer whether the player busts, or if they're under 21, or if they have 9, 10, or 11 so that they can double down, or if they have two of the same card value so that they can split. We then go through an initial deal, which deals with just the first 2 cards for each player and the dealer. And once we've completed that initial deal, we'll check whether the player has a blackjack or not. We do not check if the dealer has a blackjack at that time, because the lower card is not revealed. However, at the check blackjack stage, if the player has a 10 value and an ace value card, that BJ variable that was a member of the struct will turn from 0 to 1, so that we know that that player has a blackjack. That will then trigger if the dealer has an ace. Then instead of paying that blackjack player, we will ask everybody at the table if they want insurance, but the blackjack player will not be paid until the dealer's card is revealed. The dealer's second card is revealed. And so that's one of the reasons why we had that member variable in the player struct to track the blackjack, not just by numbers, but to put it on pause, if you will, until the dealer's bottom card is revealed. We have a for loop to deal to any players who do not have blackjack on the initial deal. So once we've determined whether any players have blackjack, we continue the game, and then we will basically generate a menu based on the player's cards. So everybody gets a standard menu, which will be a hit and a stay. And if any players have card value 1 and card value 2 to be equal the same value, then they will also view a split menu. So they'll have hit, stay, or split. If their card has a 9, 10, or 11 value total, then they would also see the double down menu. And we go through a switch statement that basically shows the options. If they were to hit, they would go through this process here, where they would be dealt a card. If they were to stay, then it would just output a message that the player is staying. If it was a split, we go through this case number 3, which initializes a second split hand, which is split bet 2, and that the split hand is true. So the computer is going to know now that they're going to deal first to that very first card and then to the second card. We reset the card total, which is a counter for all of the cards. We reset that to half, and we're going to put that one card with half of the value. And the assumption being that if we have 2 of the same cards with 2 of the same values, we just cut it in half. It'll show us the value of one card. And we set the card total for the second card to the initial value as well. So once let's just say we had 2 3s, and so the card total would have had 6. When we divide it by 2, it now becomes 3, and then we set that card total split variable to the same as this card total here. So now both of them will have that value of 3. And we prompt the player to place an additional bet for that split if they choose to split. And we make sure that they put in a matching amount, not less than their original bet or not more than their original bet. It is a even money bet on a split. And so this error handling is set up for that purpose. And then we deal cards to both hands in a for loop. So since it's two different hands, we give them the opportunity to keep hitting until they choose to stop. And as long as the card is not a bust and the player chooses to hit, then we deal the card. And after we go through that process, then we change the split hand back to false so that the game will continue to another player. If they decided to double down, we had a case for double down as well. So double down would allow them only one card, and we call the deal card, and in the deal card function, it specifically states if the player has 9, 10, or 11 total, that they only get one card. We change the first deal to false now so that the game knows that we can now move on because we're not in the initial deal anymore. At this point, we attend to the dealer's card, which we now reveal the dealer's base card, the one that's been hidden. And so we go through a while loop and a series of ifs and fors to determine what's going to happen next based on that dealer's second card being revealed. So as long as the players are in the game, which is what the status is, because if they get paid for blackjack, their status goes to false. If they break, their status also goes to false. But if they are not blackjack and their hands are under 21, then their status is true. And so we're saying while the player's status is true, they're still in the game, and it's not the first deal, we're going to look at the dealer's card, and if it's equal to 21, which is the only two cards that the dealer will have, then that will be a blackjack. And if the players doesn't have a blackjack, they're going to lose automatically. If the players bought insurance, they will get paid even money on that insurance, even though they lost their hands. That's the purpose of insurance. And then the else statement is, or the else if is, if the player has blackjack, which here is that BJ member that we talked about. If the player has blackjack, which would mean that it's equal to 1, then their hand would tie, and if they had insurance, they would get paid insurance. Else, if the dealer's card is greater than 17 and dealer's card is less than 21, then the dealer is going to stay, and we're going to compare all of the players' hands at that point. And the final else is if the dealer is less than 17, then the dealer is going to continue to draw until they hit 21 or break. At this point, the game is technically over once a dealer either breaks or wins, because it'll go through some of the other functions. And new game is going to be false, and then we're going to call a function that's going to ask the players if they want to continue, if they want to play another hand. If even one player's status is true, then we're going to deal a game. Else, if every single player says they don't want to play, then the game is done. So we turn the start BJ Boolean variable off. We make it false, and we see out game is over, no more players. And then we delete the player's memory, allocated memory, to a null pointer, and we end the game.